Okay, so yesterday we had a lesson on position versus time graphs. Today we're going to be talking about velocity versus time graphs. Basically we're going to be taking position versus time graphs and turning them into velocity versus time graphs. So I just have one little page of notes here for you. When objects move with constant velocity, which is what we've been talking about, objects moving at the same speed, right, not changing speed. The position versus time plot will have only straight lines, and that's because when objects move at a constant velocity, the position versus time plot always has the same slope, and so the position versus time plot will make a straight line. And the velocity versus time plot will only have horizontal lines. And so that's because the velocity will be constant, right? That's what we're saying up above. And so when we're drawing these first velocity versus time plots, it's just going to be horizontal lines on them. So they're actually going to be pretty easy to draw. And I'll kind of show you how to do that in this first example right here. So here we've got a position versus time plot, and then we're going to turn it into a velocity versus time plot. So the first thing we need to do is figure out for this object, what is its velocity? Now we've been doing that over the past few days. Again, we do that by finding the slope. So this is, first we're just going to put the rise and the run on the graph, and then we'll calculate what the rise and the run are. The rise should be 1 meter for this graph, and the run should be 2 seconds as we go from 1 second to 3 seconds. Okay, and so then we're going to divide the rise by the run, so 1 meter divided by 2 seconds, and that equals 0.5 meters per second. And so then we're just going to plot a horizontal line on this velocity versus time graph at 0.5 seconds, so just a straight line across. And we're doing it at 0.5 seconds, so halfway in between 0 and 1, because that's what the slope was, 0.5 meters per second. Okay, let's do another example. This one, we can see that this graph has a negative velocity, right? It's going down as we go to the right. So that means that this object's moving backwards. We'll put the rise and the run on. We can see that this moves down 1 meter from 3 to 2 and over by 1 second. So the slope becomes negative 1 meter over 1 second, which is equal to negative 1 meters per second. So then we're going to graph a horizontal line at negative 1. So right here. Now notice this one, because this graph only goes from 0 to 4 seconds, my graph over here also only goes from 0 to 4 seconds. I don't add any times that weren't on the original position versus time graph. So that'll be important when we get to example 4. All right, let's do one more example here. Here we've got a graph with a flat line, flat position versus time plot. And remember, that means that the velocity is 0 meters per second. This object isn't moving. It's stuck at a position of 3 meters. It hasn't moved from that spot. And so what that means is that the velocity is going to be 0 meters per second, and so we're going to plot a horizontal line at 0. So hopefully that's pretty clear. Okay, so now let's do a little bit more complicated example. Whoops. So this one, example 4, we've got a plot, and we can see that there's a couple different segments on there where we've got an object moving at a constant velocity. So we're first going to calculate the velocity of this first segment, this blue segment right here. So we'll put the rise and the run on the graph. We can see that the graph between these 2 points moves up by 1 meter, and it moves over by 1 second. And so then the velocity we'll calculate that by taking 1 meter divided by 1 second, which equals 1 meter per second. Okay, and so then we'll plot a horizontal line at 1, and we're going to do it from 0 to 3, because that's the length of the blue segment, the length of time, from 0 to 3. From 0 to 3, I'm going to plot a blue line right here. Next, we're going to do the same thing for the red segment. We're going to calculate the velocity first. Well, again, this is one of those flat lines, so it should be pretty easy to do the velocity. It should be 0 meters per second. And so we will do a horizontal line at 0 on the velocity versus time graph, and we'll do that from 3 to 5. So starting at 3 and then ending at 5. Okay? And then last, we're going to do this orange segment. So we'll add on the rise and the run. We can see that from this point to this point, it goes down by -1 meter, and it goes over by 2 seconds. So then when we calculate the velocity, that's -1 meter over 2 seconds. And that equals, okay, sorry about that, there's a little typo there that I had to go fix. It was -0, the slope is going to be -0.5 meters per second. And so then this segment goes from 5 to 11. So we will plot at -1/2 from 5 to 11. Okay, so hopefully that makes sense there. All right, and so then for example 5, what we're going to do is write a short story about this graph. Lucia, you don't have to write any of this down. Just sort of pay attention because you're going to do a problem like this, and so your problem doesn't have to be exactly like this, or your story doesn't have to be exactly like this, but something similar sort of idea. So Lucia walked from her desk to the pencil sharpener in 3 seconds. So we can tell that because she goes from 0 to 3, right? That's 3 seconds. She walked at a fairly brisk pace of 1 meters per second. Right? We calculated that on the last example, the slope of this blue line. The pencil sharpener was 3 meters away from her desk, right? We can tell because this red line is at 3 meters, right? That's where she's stopped at the pencil sharpener. Lucia then stood, right? So stood indicates that she's not moving. We know she's not moving because the slope of this line is 0 meters per second. She stood at the sharpener and sharpened her pencil for 2 seconds. We know she was there for 2 seconds because it goes from 3 to 5 seconds. She then walked slowly back to her desk at another typo. Sorry about that, folks. Another typo. She walked slowly back to her desk at a pace of -0.5 meters per second. And so again, we calculated this slope on the last slide. So just look at your notes from the last slide if you want to see where I'm getting that from. It took her 6 seconds to get back to her desk. 5, 6, 7, 8, 9, 10, 11. 11 minus 5 is 6. Okay, then what you're going to do is go through these practice problems. You're going to take these graphs, turn them into velocity versus time graphs. That should be pretty straightforward. Nothing too tricky there. Problem 4 is one of those ones with multiple segments. So you're going to plot multiple segments on this velocity versus time graph. Problem 5 though, so what you're going to do is you're going to do what I did in an example 5, is you're going to write a story on the next page using the information from this position versus time graph. So your story needs to include 6 total pieces, I should say at least 6 total pieces of information about the time, position, and velocity of this object or person. So make up a story. Maybe it's, you know, a toy car. Maybe it's a swimmer. Maybe it's a, I don't know, a dog. Maybe it's you. It doesn't really matter, but make up a story involving this position versus time graph, kind of like I did. And so you need to include 6 total pieces of information from this graph. You've got to tell me at least one piece of information about time, one piece of information about um, the position, and one piece of information about velocity, right? So you can't just tell me all about the positions or all about the times or all about the velocities when you tell your story. And then you've got to give me one piece of information from each segment too, right? So you can't just only talk about the orange segment. You can't just only talk about the red segment. You can't just only talk about the blue segment. You got to talk about all three. Um, just kind of like I did in my example here, right? I gave you two pieces of information about the blue segment. I gave you three pieces of information about the red segment. I gave you two pieces of information about the orange segment. I gave you two different velocities. I gave you two different positions, right? Oh no, I guess I only gave you one position. I gave you three different velocities, right? 1 meter per second. The fact that she was standing tells you that her velocity was 0. And then this velocity down here. I gave you one position, so the 3 meters, and then I gave you two different times, right? The 3 seconds to walk there. Oh, three different times actually. 3 seconds to walk there, 2 seconds at the pencil sharpener, 6 seconds to walk back. So the point is you need to have one piece of information about the blue segment, one piece of information about the red segment, one piece of information about the orange segment, and you need to have at least one time, at least one position, and at least one velocity. If you're confused if you are confused at all about any of that, uh, send me a message and I'll clarify that for you. But hopefully that should make sense. Okay, so give that a try. Let me know if you have any questions, all right?